All right, here we go. It's PSAT 2022. This was the October version. We're on the calculator section, so let's get after it. Number one, I see the word mean and median in here, so this is a statistics problem. Looks like they're wanting us to compare the mean and the median. So let's look at it. Well, the median's the easiest one. So you put them in order from small to big. So you got 25, you got a couple 30s. Just kind of scratch these out as I do them so I know I count everybody. We got a 35, we got a 40, and 75, and an 80. All right, so 7 days in a week, so there's an exact middle number. The middle number is 35. And just looking at this, I can see that there's a lot more pizzas that were being sold there at the high end compared to the low end. So I know that the mean, the average, the mean is going to be greater than the median. You could add them up really quick and divide by 7 if you really wanted to find it. The median's 35, but that takes time. I can do it really fast. 5, 10, 15. Add the 1, 3, 6, 9, 12, 16, 23, 31. So 315. See how many times 7 goes in there. Right away, I'm already at a 4. Looks like 45. So the average is 45. The median was 35. But I could see how much bigger the numbers were than the median. So this one, the mean is greater. So the correct answer here is B. So number 2, we have a chart with some missing values. Number of students who attend assembly. Looks like we have a clue buried in here that the number of freshmen is 4 times the number of seniors. All right, so we have freshmen, we have seniors. The number of whatever the seniors are, the freshmen are 4 times that amount. Well, let's see what we got. There's 180 total. So if I put this together, that's 90. So subtract 90 from the total. That means we have 90 left. So our freshmen and our seniors equal 90. So let's add them up, make them equal 90. We get 5x is 90, divide. X equals, looks like 18. So there would be 18 seniors. And 4 18s, that's a double-double, 36, 72. And then the question says, how many freshmen? So notice they do have this answer of 18, but that would have been pretty sad to do all that work and choose the wrong one. Correct answer is C. You also could have just started playing with the numbers until it worked out. For some people, that might be faster. All right, number 3 is a good old-fashioned tax tip discount. We hammer this really hard in our prep class. So the Iowa State sales tax is 6%. Shirt cost $15 before tax was added. What was it after? So this is an easy one. You have a $15, so this is our start. And tax is an increase. So I'm going to go 1 plus the percentage. So 1 plus 0.06. And then that should give us the ending amount. So you could use your calculator and do 1.06. Some of you might just quickly be able to do 6% of 15 in your head. 6 times 15, that's 90. So it looks like the correct answer is going to be B. All right, number 4 is just a physics question. It's pretty simple, but you have to have it memorized. You have to know the density and volume and mass. So the formula is density equals mass divided by volume. And then they always give you 2 out of the 3. So this one says, what is the density? So we don't know D. But the mass is 20. And the volume is 5. And 20 divided by 5 is 4. All right, number 5. This is a stats problem with box plots. So the big thing is knowing how to read the box plot. It basically breaks it up into quartiles. So this first line is the lowest value. The end whisker is the highest value. And this is the 25% of the data. And this one is 75% right here. Those are the ends of the box. And then the line inside the box, well, that represents the 50% mark, aka the median. So this thing breaks it up into quartiles, Q1, 2, 3, and 4. And this question asks about the two medians. It says, how much greater is the median of 2 than it is of 1? Well, the second one has a median of 9. The first one has a median of 6. So how much greater is that? Correct answer is 3. All right, number 6, we have a scatter plot, best fit line. They want to know slope. Which of the following is closest to slope? Let me just zoom out a teeny bit so I can see all the choices. So slope of the line is change in y over change in x. So I'm going to pick a couple points on the line. I like to pick the numbers that are nice and clean. So it looks like 1, 4 is on there. And I don't know, there's another number right here that looks pretty good. That's 5, 16. So it looks like we're going up from 4 to 16. So that's 12. And then we're going from 1 to 5. That's 4. And it's the rise of the change in y over x. So it's 12 over 4, which should have a slope of 3. Correct answer is C. All right, number 7, table shows selected values of a function. Which of the following is the best description of this function? So I'm looking at it and I see that as x gets bigger, the y value gets bigger. So I know it's increasing, so that wipes out A and C. So I have it down to a 50-50. But it's definitely not linear because, you know, here as x goes up by 1, y goes up by 1. But then here as x goes up by 1, y goes up by 2. So when you're going up by different amounts, that is not linear, so it's got to be D, exponential. All right, we have one of these story problems that spans, looks like 8, 9, and 10. It's a linear equation, so this is what they call, or I call, interpreting a linear model. So they're giving me a linear model of a story problem. We just have to answer some questions. First one just looks like a plug and chug. It says, at what temp? So basically, find T when the width is 11.25. So they're telling me what W is. I just have to find out what T is. So I go up here, and this is on the calculator version. So if I know W, and I have to solve, 0.5, I got to solve for T. So first thing I'm going to do is I'm going to subtract the 20.5 from both sides. Subtract 20.5. And what's that going to be? Get my calculator because I'm going to have to divide by this negative 0.37. Anyway, so I'm getting negative 9.25. And then divide by negative 0.37. Divide by negative 0.37. It's going to be a number around 20-something, maybe the 32. Divided by negative 0.37. 25. Correct answer. All right, number 9, they want me to match the graph of the equation up above. So up above we had W equals 20.5 minus 0.37 T. So our y-intercept is right here. If T is 0, we're going to have a W of 20.5. So that's, you know, I see that here. I don't see it on this one. I don't see it in the right place on this one. This one I see it, but man, that line's pretty flat. And I know my slope is dropping negative 0.37 every T. So like if I were to drop 10 degrees in temperature, I should drop negative 3.7. So, you know, as we move over from 0 to 10 degrees in temperature, this one looks about right. That looks like it dropped somewhere around 3 or 4. So the correct answer here is going to be B. All right, number 10, final question dealing with this equation. Which inequality best describes all the temperatures that correspond to a gap width between blah, 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 blah. So what we need to do is we need to plug at least one of these numbers in, because it looks like this is on the low side, this is on the high side. So let's plug in the 13.1. So 13.1 for the width, 20.5, subtract 0.37t. I'm going to minus that 20.5, minus the 20.5. Boom. So that's going to be, oh, I have to divide by the 0.37. Let's just do it all. 13.1, take away 20.5 is negative 7.4 equals negative 0.37t. Divide both sides by negative 0.37. And it looks like t is going to come out to be 20. So it looks like that's the small one. I'm not going to plug in the other one, but if I put 16.8 and did the process over again, I believe we would get 30. So we're going to go with D. All right, number 11 is another statistics equation. This girl bought some dice, and kind of like a Dungeons and Dragons type dice with polyhedral, different number of sides, and they're distributed a certain way, and it wants to know about standard deviation. Anytime on the SAT, they're talking about standard deviation, that's just the spread of the data. It's how spread out the data is. All right, and if it's really spread out, it's going to be a high standard deviation. It's going to be lower if it's tighter. So if you notice this first batch, everything is between 6 and 14. All the data is right there between 6 and 14. If you look over here, the data goes all the way from 4 to 16. So this one is more spread out. So this one is going to have a higher or a larger standard deviation. So company Z is going to have a higher standard deviation. So the medians are the same. So I didn't even see the little median part. It does look like the medians are going to be the same though, because there's like an exact same amount on each side. It's balanced all the way across. So I believe they both have the same median, but standard deviations are going to be different. So since the medians are the same, that wipes out these guys. And standard deviations are different. So the correct answer here is going to be A. Number 12 is a conversion problem. So this is kind of like what you do in science class. I've seen it done a few different ways, but I'll just kind of roll with the way that I've seen our science teachers teach it. So it flows at a rate of 11.8 inches per year. We need to get 2 meters per year. So when I set that up, I kind of set it up as a ratio. So 11.8 inches for 1 year. And I need to end up with, way over here, I need to end up with meters per year. So I'm not going to monkey with the year. I'm going to be good on that. But somehow I got to get from inches to meters. And there's a few steps in between. I need to get from inches to feet because they give me this conversion. And it's not equals. I'm going to actually be multiplying here. So if I want to get rid of those inches, because I need to get to meters, I need to put inches on the bottom, and I got to use that conversion. So 12 inches is 1 foot, which is basically 1. 1 foot over 12 inches, they're the same thing. So I'm not hurting anything. That's just times 1. But it allows me to cancel these inches off. Well, now I got to get rid of feet, and I can use this feet-meter relationship. So since feet are on top, I'm going to put feet on the bottom, and 3.28 feet is equivalent to 1 meter. And so now I believe I'm going to be in good shape because I'm going to cancel these feet off. And all I have left are meters on top, years on the bottom. Now I just need to multiply my top numbers, multiply my bottom numbers. Well, 11.8 times 1 times 1, that's just 11.8, and I have meters on top. And on bottom, I have 1 times 12 times 3.28. So 12 times 3.28 is 39.36. And then finally, I divide those out. 0.8 divided by 39.36. I get 0.299. So that's pretty doggone close to 0.30. Correct answer is A. All right, 13 and 14 says we have a scatter plot, forearm mass index in kilogram per square meters, and the blood glucose per liter of bats. So that's kind of crazy. A line of best fit is also shown. So let's see what they want. 13, which of the following is closest to the range? So that's kind of like the high minus the low. So the range of the blood glucose concentration. So blood glucose is over here on the side. So the range looks like it goes from 4 to almost 10. You know, so I don't know, maybe 9.5 all the way down to 4. So somewhere around 5.5 would be the range. Correct answer B. All right, number 14, which of the following is closest to the forearm mass in grams per square centimeter of the bat species with the lowest blood glucose? All right, so let's go back to the chart. See who had the lowest blood glucose, and then we got to find their forearm mass. So lowest blood glucose would be this dude right here. So 4 is the lowest blood glucose, and the forearm mass is 6. All right, so we got to go down here, and that was 6 kg per m squared. So 6 kg per m squared. All right, 6 kg per m squared. But we need to get grams per square centimeter. So we need to get grams per square centimeter. So we got to do some changes. We got to get rid of some things. So it says 1 kg is 1,000 grams. So I need to get rid of that kilogram. So I'm going to put it on bottom. 1 kg is 1,000 grams. So now I can cancel out kgs because I have one on top, one on bottom. And I got my g's. But now we got to get rid of the meters squared. And since meter squared is on bottom, I need to put it on top to cancel it out. And 1 meter squared is 10,000 square centimeters. So 10,000 square centimeters. So I now can cancel out my meters because they're on one on top, one on bottom. So now we just got to multiply 6 times 1,000. So we have 6,000 grams. And on bottom, we have 10,000 centimeters squared. So when you cancel out a whole bunch of zeros, 6/10, which is roughly 0.6. 6/10 would be 0.6. So it looks like the correct answer here is going to be C. All right, number 15 looks like it's another modeling question. This time it's a quadratic. P is the population. N is the number of years after 1960. They always do that. So according to this function, how many years after 1960 was the population the greatest? All right, so basically, I have some years here. I could kind of put those years in and see who I had the highest number. Like that could possibly be one way to do it. I also just kind of know that this is in vertex form. We have one like this, I believe, on the Oct Calculator. So vertex form, it's this negative ax minus h squared plus k. And I get some information about that. Whenever you have a negative in front, I know it's going to be a quadratic that looks like this. The a part is going to stretch it, so it's going to be pretty narrow. But I know that the vertex is going to be at hk. Well, h is 42, and k is at 57,140. And I know that the vertex for a parabola that opens down, that's concave down, The maximum is going to occur right here. It's going to occur right at the top, right at that vertex. So according to this function, how many years after 1960 was it the greatest? Well, it's going to be 42 years. So you had to know quadratic vertex form for that one. All right, number 16 looks like a kind of complicated equation. Looks like it's exponential. But when I see this, what is the y-intercept? I know it's not going to be too bad. Let x equal 0, and that'll find the y-intercept. So I have 6 times 1/2 to the 0 power, subtract 3. So I do my exponents first. Anything to the 0 power is 1. 6 times 1, take away 3. 6 take away 3 is 3. So when x is 0, y is 3. Correct answer, D. So 17, we have an expression. We got to figure out who's equivalent. It looks like they factored out a GCF. So this is kind of like reverse distributive property. So we could just distribute and see which one makes the first one. So right away, that's going to give me a 15. Well, this is only going to give me 2 terms. This is only going to give me 2 terms, so they're out. This one would be 5xy plus, that would be 15x squared y, looking good so far. And then this would be 20xy squared, which is what we need. So the correct answer here is going to be C. All right, number 18, we have a line intersecting a circle. So we kind of need to know a few different pieces of information here. So first of all, let me set up a little bit of a graph. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And one thing you need to know is the equation for a circle. X squared plus y squared equals r squared. And this is centered at 0, 0. So I have a center at 0, 0. And if r squared is 16, then that means when I take square root of both sides, it looks like r could be plus or minus 4. So the radius is going to go all the way out to 4 in every direction. So we kind of have this, there's our circle. And then it says the equation with the line x equals 0. Well, whenever it's x equals some number, those are vertical lines. So they're basically talking about this is the line x equals 0. And it looks like it intersects right there at 0, 4. And then it is right there at 0, -4. And it looks like the only one that's up there is B. All right, number 19. I hate these problems. These to me are like some of the stupidest problems because they seem so easy, but then they make you think about it like in a weird way. But it said Terrell made 48 cups of jam. He filled X small jars, Y number of large jars. So then you have this equation, X plus 2Y equals 48. And this is the cups. And remember, this is the number of jars. And this Y is the number of jars. So I kind of made a table because I was like, this can't be this easy. So let me just kind of crank out some numbers. And I just said, what if I had 10 jars, 10 of the small jars? And so I solved it, and I minus 10 from both sides, and I got Y equaled 19. So that told me that if Y means that I had 19 jars, but then that came out to be 38 cups, then this expression here, this 2Y expression, if Y is jars, this must be the total number of cups that are in the large jars. So the correct answer here is D. Don't really like that question. I could see a lot of people picking B, but it said Y represented the number of large jars. So 2Y wouldn't be that. It would be the number of cups of jam. Dumb question in my opinion. Number 20, pretty common question. Almost every single SAT has one of these probability two-way table. We hit these pretty hard. So we have some ice cream flavors and sprinkles, no sprinkles. If a customer order is selected at random, what is the probability of selecting an order with sprinkles? So what is the chance of selecting an order with sprinkles? Here's the most important part. Given, so this is going to be our bottom number, given the flavor is vanilla. So we're only looking at, we're given that the flavor is vanilla. All right? So there's only 40 possibilities there. And what's the chance that we're going to select an order with sprinkles? Well, with sprinkles, that's 30 out of 40. So that would be a 75% chance, 0.75, correct answer, C. All right, number 21, if x is a positive number and x is 160% of y, let's write that down. X is 160%, so 1.60 of means times. What is the expression of y in terms of x? So that means solve it for y. So divide both sides, and 1 divided by 1.6 is 1 divided by 1.6 is 0.625 x equals y in terms of x. The correct answer here is B. All right, number 22, you don't see absolute value a whole lot. If you do, you usually only see one of these. So it says, what is the sum of the solutions? So anytime you do absolute value, there's two options. So remember, how could I get an answer of 24? Well, absolute value means take whatever's inside and make it positive. So there's actually two possibilities. The absolute value of positive 24 is 24. But the absolute value of negative 24 is also 24. So I have to kind of create the two scenarios and say, well, when is this stuff going to equal positive 24? So when is x plus 11 going to be 24? Well, that's x is 30. Let me see, minus 11. So that's 13. And then I have to figure out, well, when is x plus 11 going to equal negative 24? And I minus 11 to both of them, and I get negative 35. So these are my two solutions. But then they want to know the sum. Sum means add. So I need to add my two solutions. 13 plus a negative 35. Add those up. It looks like I'm going to get negative 22. So the only negative number. So you probably wouldn't have just picked that if you were guessing. All right, number 23 says the ratio of a rectangle's width to length is 4 to 9. So let me kind of write that down. The width to the length ratio is 4 to 9. If the width of the rectangle is W, which expression represents the length? So how do I get the length? Well, I can cross multiply here, and I can go 4L is 9W. And which expression represents the length? So to find L, I divide both sides by 4. So the length is 9 over 4W. Correct answer, B. All right, number 24, we got a graph. Systems of equations, blah, 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 a bunch of story problems. Which of the following systems represents, or equations represents this? Well, what I'm going to do is I see the solution to the system. That point right there when x is 1500, y is 9000, satisfies both equations. So I'm going to just quickly try to plug this in. 1500 and 9000. So let's let x be 1500 and y be 9000. And let's just kind of go through and plug them in. Just quickly looking at it, if I plug in 1500 right there, 60 times 1500 is a huge number. And if I stick 9,000 there and then I add that up, I'm going to get way more than 100. So I know it can't be U. I'm also going to get way more than 510. So I think we're down to just the top part. And now I'm just going to put in my calculator, whatever's fastest. Maybe I'll just put it in this bottom part, I don't know. Let's go 1,500. 1,500 divided by 60 is 25. And then 9,000 divided by 120 is 75. Hey, that works. So, and if I put it in here, 25 plus 75 wouldn't work. So I think the only one it works for is A. I could try the bottom two, 0.04 times 1,500 plus 0.05 times 9,000. And yep, checks out to be 510. So the correct answer is A. All right, next problem, another geometry one, number 25. Talking about the volume of a cone. And you may have to go to the front page if you don't remember the formula for this, but they give it to you. Volume of a cone is 1/3 of the volume of a cylinder, which is pi r squared h. And cone T is shown here. So that's the equation for cone T. But it says cone W, which is not shown, is way smaller. It's like 1/27th the size. So somehow I need to get the exact same equation, but 1/27th of that. So when I'm going through and I'm looking at all these radiuses and heights, when you look at, you have to do, basically they're going to start off the same. 1/3 pi is going to be 1/3 pi. But you do radius squared, which is radius times itself, times height. So I need that to come out to be 1/27th. So when I look at this one right here, if the radius is 1/3 r, and then another 1/3 r, because it's squared, and then the height is 1/3, well, that's going to give me my 1/27th size that I need. So the correct answer there is C. A little bit tricky. All right, number 26, one of the two linear equations is given. The system has no solution. So the big thing you need to understand is, when do you have no solution? Well, no solution graphically is when you have two lines that never cross. So they have the same slope, but they have different y-intercepts. So that's a scenario where you have no solution. Infinite solution means you have the same slope, but they're right on top of each other. It has the same y-intercept. Another way to think of it is, like this equation right here has no solution, because no matter what x I put in there, the right side's always going to be one bigger than the left side. And when you try to solve it, you basically lose all of your variables, and you end up with a false statement. So that's another way to view no solution. So however I want to look at that, I'm going to kind of do, I think, kind of the algebra way, just looking at this. I don't really feel like monkeying with slopes. So if I divide everybody up here by 2, which I'm allowed to do, I get x minus 6y equals 4. Well, that's exactly what A is. So these would be the exact same, and this would be an infinite solution. So I know it's not A. X minus 4y equals 0, that's not going to work out because my y's aren't going to disappear. You know, if I do x minus 4y equals 0, and then I subtract those two equations, I'm going to still have some y's left. I wanted everything to disappear, so that's not going to work out for me. If I come down here and I double everything, if I just multiply this entire thing by 2, well, that will give me x minus 6y equals 4. Well, that's the exact same. That would be another infinite solution scenario. Hopefully it's this last one. Let's just check it out. So if I double everything down here, I'm going to get x minus 6y equals 0. Well, that's perfect, because if you notice, remember what we had up above, we had x minus 6y equals 4, and now we have x minus 6y equals 0. And if we try to solve this using elimination, you know, I would probably teach people to get some opposites. So I would probably distribute a -1 through one of those equations. So I don't know, maybe I'll leave the top alone, and I'm going to distribute -1 through the bottom. And then when I combine them, I'll get 0 x's, 0 y's, and on the right I would get 4. And this would give me my false statement. So that's what no solution means. You're going to get a false statement. Correct answer here is D. All right, number 27. This one should be in our wheelhouse. This is the multiple percent problem. We're increasing and decreasing and doing a bunch of stuff. So the value of a house, which they don't tell us, I don't know what it is. So that's my starting amount. Increased 8%. So an increase of 8% means we're going to add 8% to 1. Then it decreased by 3%. So when you decrease by 3%, you subtract. So that's going to be a 0.97. What was the net percentage increase for the 2 years? So basically, what do you get when you do both of these together? So I'm going to multiply those together. 1.08 times 97. I end up with 1.0476 times the value of the house. So my growth is going to be right there, which is going to be 4.76% growth. Correct answer is A. All right, number 28. I think this one was probably one of the toughest on the test for me. Quadratic function can be used to model the height, object above the ground, blah, 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 blah. So they give me a little bit of information. So I have an idea of what this looks like. It said it was launched from the ground, so from 0 feet, and it reached its max at 3136. So this is my feet, and 14 seconds after it was launched. All right, so right about there, which tells me then at 28 seconds, because it's symmetrical, it's going to hit the ground. So this thing went up, then came back down. And it says, based on the model, what was the height? So find h when we were 1 second after it was launched. You know, so if this is t, and over here is my h, basically it wants to know, you know, at 1 second, what is the h? So I need to know a little bit about setting this up. And since they gave me this max here, it's actually, that's the vertex. So the vertex is at 14, 3136. So I'm going to write this thing in vertex form. So we have y equals a times x minus h squared plus k. And hk is our vertex, so we have y equals, and I know a has got to be negative here, but I have x minus 14 squared plus 3136. And then because this is a gravity problem, I know this one starts off -16 x squared, because we've kind of talked about this earlier, but when you're talking about feet on Earth, it's a general equation that's kind of good to know. I think you probably have to know it on this one. But the height as a function of time, it's -16 t squared plus the initial velocity t plus the starting height. So that's kind of an equation that we would need to know. And I know that the front here had to be -16. In front of the x squared term. So I know a is -16. And now since I have pretty much the whole equation, I have the gravity in the front and the vertex form, I believe I can just stick 1 in there for x or for t and figure out what it is. So -16 times at 1 second. And this should calculate the feet for me. So -13 squared, well, that's 169. So -16 times 169 plus 3136. I'm going to go to the calculator. Negative 16 times 169 plus 3136 is, I got 432 feet. So I don't know, there might be another way to do this one, but I'm pretty sure the vertex form is what we need. And then this gravitational constant in front, it kind of comes from physics. I think you'd have to know that as well. But I believe the answer is 432. All right, number 29, very strange problem, and I think it almost seems too easy to be this, but if 2x plus 3 over 5 plus 1 equals 4/5 plus 1, well, if I subtract the 1's from both sides, I basically have, 2x plus 3 over 5 equals 4 over 5. So, if those two are equal, these top pieces have to be equal. And it says, what's the value of 2x plus 3? I think the answer here is just 4.